In this class, we're going to consider how you solve linear equations. So the first thing is, what is an equation? What is a linear equation? What does it mean to solve them? There's quite a lot to unpack before we kind of get into the mechanics. So these guys are all linear equations, and when students hear the term linear equation, they assume that it's a reference to the line, the fact that these are all like on a line. It seems to make sense, linear. It's not actually that, because you could have, for example, a fraction, say 2/3 x equals 7/4, something like that. That's still a linear equation. The thing that makes it linear is not the fact that it's on a line, it's the fact that the x terms, which are your variable, have just got a power of 1 on them. So in other words, you're not going to see like an x cubed, x squared, or an x cubed or something like that in a linear equation. So you're only going to have like an x term, like an x to the power of 1. That's the thing that makes it a linear equation, but that also has a knock-on effect to mean that linear equations only have one solution. And we'll see that as we work through these. There's no way to get more than one solution. When you move up to other types of equation, like if I put a power of 2 on there, an x squared, then you would get potentially 2 solutions. If you had an x cubed there, you get potentially 3 solutions. That's just the nature of how different orders, as they're called, of equation work. But we're not concerned with all of those. We only care about linear equations today. Linear equations are super important. I cannot emphasize enough how much time you should spend on these. If you're taking an algebra class, if you're taking pre-calculus, if you're taking calculus, doesn't matter what high schoolish level, even through to college level math course you're taking, these guys are going to be with you for a long time. So they're not massively difficult, but at first they are, like everything else, difficult, but they're worth spending time with, because once you get really good at them, you can just get so good at them that they become almost like writing. They're almost like writing in English. This is the language of mathematics here. You've got to be quite fluent with these. So that's my motivational speech over, but really spend some time on these. They're super important. They just take the pressure off. They reduce your anxiety about solving loads of math problems, because almost every math problem turns into an equation at some point. Even if it's a geometry question, even if it starts off life nothing like an equation, it normally morphs into an equation at some point. If you get it to that point and then you're like, it's an equation, how do I do those again? It's going to be stressful like every time. If you get to this point, you're like, yeah, it's an equation, I know what to do there, and you just flow through it, then that's a much more empowering place to be. So what does it mean to solve an equation? Well, equations are made up from these terms, and they've obviously got an equals, they've got a variable. Sometimes they'll have more than one version of the variable. We'll see different variations. There's lots of variations of linear equations. They're formatted in different ways. But to solve it basically means to find the value of the variable. What number does x represent to satisfy that equation? And what does it mean to satisfy an equation? Well, an equation represents equal quantities. So the thing on the left-hand side and the right-hand side of the equation are balanced. So that's a good way to think of it. This is balanced, but it's only balanced if we find the correct value for x. Finding the correct x, solving the equation, in other words, keeps the equation balanced. And that's effectively how we approach equations. We try to work through a series of steps that keep them balanced until we can figure out what the x value is. You can look at equations, very simple ones, and just try to guesstimate the value. So you could look at this and say, well, okay, this bit here needs to be some number so that when I take away 3, I get 13. Well, that would have to be 16. And if it's 4 times something to give you 16, then the x would have to be 4. And that's correct, and that's great, and it's great to be able to do that. As they get more difficult though, that process will break down. It's going to get really difficult to try and figure it all out there, so we need to go through sequential steps. Even if you can do that, you still need to show how you get through the working. You need to show your working, you need to show how you get to the final answer anyway. So the approach that we basically take with these is to keep in mind that what we eventually want, after a few lines of working, maybe 2 lines, 3 lines, for more difficult equations, maybe 5 or 6 lines, to get to the point where we've got x here equals, and then whatever the numerical value is. So effectively what we're trying to do is to get the x on one side of the equation and get everything else on the other. So it kind of becomes more of a case of rearranging the algebra. Solving equations are effectively just rearranging the equation for the variable that you're trying to solve for. So if you've already done rearranging formulas or changing the subject of formulas, that is all that solving equations really is, but just in a way that you get a numerical value at the end rather than a rejumbling of a bunch of algebraic terms. So keeping that in mind, that's what we're going to try and do. So we're going to try and eventually move this -3 to the other side, move the 4 to the other side, and we just need to learn a few rules, if you don't know them already, about how we do that. And the main rule is, the primary rule that I cannot emphasize enough to you, is that when something crosses over the equals sign, so this is on the, let's call this here the left-hand side, so the left-hand side of the equation, this here, everything over here is the right-hand side. When something moves from the left to the right or from the right to the left, it changes its sign, so a plus becomes a minus becomes a plus, or it changes, if it's a times, a multiply to a divide, or a divide to a multiply. It also changes from a squared to a square root, a square root to a squared. Everything changes to the opposite operation, the inverse operation on the other side. Don't need to think about that too much, you'll just get used to it as you go along. But basically here, the first thing we're going to do is move that 3 over to the other side, the -3, but it becomes a +3 on the other side. Okay, so it's going to be like that. So we can go ahead then at this point and just add those, because 13 and 3 is 16. And then we see 4x. Well, 4x, remember, means 4 times x, 4 multiplied to x. So if we move that 4 to the other side, we just think, right, we do the opposite of multiplying, which is dividing. So we would get 16 divided by 4, like that. And then we could just go ahead and solve that and get 4. 4 was the answer that we kind of figured out already. That's just validated that 4 is the correct answer. That's how we get to the final answer. So just maybe worth checking that that is a solution. So 4 times 4 is 16. 16 minus 3 is 13. So the equation is kind of balanced. That's the kind of steps that we need to go through to solve equations. Let's take a look at this guy. Similar thing going on here, similar format. So generally the last step in solving an equation will be a divide. That's the thing we want to save until last. We want to gather all the numbers on the other side first before we divide. You can divide at this step, but if we divide by 7, 12 doesn't divide by 7, neither does 22, so you're going to introduce fractions, which just makes it more difficult. The other thing to bear in mind, solutions to equations don't have to be whole numbers. They can be fractions, they can be decimals, they can be negative numbers. You're going to get all sorts of variations, okay? So this one, same thing, we're just going to move the 12 over, but the 12 becomes a -12, like that. 22 minus 12 is 10. You don't need to keep the 7x in the same place. You can move it over there to kind of fill in that space if you like. And then at this point, we're going to divide by 7. 10 doesn't actually divide by 7 to give you a whole number, so we'll just leave the answer as 10 over 7. So 10 over 7 is the value that satisfies that equation. We could check that by doing 7 times 10 over 7. So 7 times 10 over 7 plus 12. Well, 7 times 10 over 7 is 70 over 7, which is just 10. So we would end up with 10 plus 12. 10 plus 12 is 22, and that's what we wanted. So that validates that the single one solution to that equation is 10 over 7. So don't freak out if you see solutions like that. They can be like that. It's always friendlier when they come out to be a nice number like 4, but 10 over 7 is very possible. It is, however, probably worth checking if you get a less friendly number like 10 over 7. It might just be worth checking you're working, because most equations, I would say, are designed to come out to be whole number solutions. These maybe form less than 20% of your equation solution. So if you do get one of these, you might just want to quickly check, hey, did I make a mistake there? Could just be a little numerical error, like did I add these instead of subtracting or something like that. Okay, so having a look at these last two. So these ones have got 4 terms. It doesn't matter how many terms you've got, we're just going to do the same thing. What we're going to do with this one though, we're going to start by taking the x terms over to the left. We want to gather all the x's on the left, all the numbers on the right, and then divide at the end. So we've got a minus 3x here. We want to bring that to the other side. So it's swapping from the right over to the left. That means the minus becomes a plus. So we're going to get 2x plus 3x. I'm just going to write the 2x terms together. We'll leave the negative 6 there on the left-hand side and leave the 14 on the right. So effectively all I've done there is take that guy and move him over to the left. 2x plus 3x is 5x. Minus 6 equals 14. The minus 6 we need to put on the other side, the right-hand side. So we're going to get 5x equals 14 plus 6. You don't need to write the plus 6 in. I've been writing everything in line by line. As you get more comfortable with these, you'll start to skip a few of the lines. So 14 plus 6 will be 20. So you can go straight to 20 if you like. The same for the final line. You can say, right, it's going to be 20 divided by 5, which is 4. You can write in 20 over 5 if you wish, or you could just go straight to x equals 4. Either of those is acceptable. Okay, so just taking that same idea onto our last example here. By the way, it doesn't matter if you gather the x's on the right-hand side or the left, but the convention is to gather them on the left. And that's really just because we read left to right, I think. There will be times when it might be more convenient to gather the x's on the right. You get the same answer either way. Equations don't care if you read them left to right or right to left. You can even spin them around to change them. It doesn't matter, but generally we try and use the x's, keep the x's on the left. So bringing that x, that minus x over to this side, to the left-hand side, would give you a plus x. 4x plus x is 5x. On the same line of working, I'm just going to take the 2 to the other side, but it becomes a minus 2, so it'll be 17 minus 2 to give you 15. Once you've got enough experience of these, you'll start dropping the lines of working and just start to do what I did there, like more than one move on one line of working. The only thing I would say with that at first, if these are new to you, just be ultra careful with those. Maybe take enough lines of working initially until you're comfortable, and then you'll just naturally start to do more than one thing on each line of working. So dividing both sides by 5, we would get x equals 3. And that's our solution for that guy. So equations, again, cannot emphasize enough how important linear equations are. They're kind of the foundation for solving just millions of math problems. And if you're just starting these, you've probably got a bit of time left in your math career. So you're probably going to be with these guys for quite some time to come. They can just make your life a whole lot easier if you can get down with them. They do require practice for sure. So I would recommend doing a whole bunch of practice questions on this topic. I mean, sorry to say it, but probably like hundreds of practice questions. And you'll probably do that anyway in your math class. If not, put in that extra effort to do that because it will serve you well in the long run. Part of the challenge is the fact that every equation looks a little bit different. You've just got to see enough of them to get comfortable with the different formats and not to be thrown off. So make sure that everything that I've said there makes sense to you, and then once it does, then fire into some practice questions. Lots of them.